Number 6. I've been doing a lot of elimination. Usually elimination is the route to go. So I'm going to continue with that. Now you have to be proficient in all 3 methods. Another word for elimination, I told the kids in class, is combination. I like to call it elimination because that's what your goal is. You're trying to eliminate, but it's called combination because you're actually combining these 2 equations. So let's say that this is a 2x and that's a 3x. Well, they are 2x and 3x. I need them to be opposite in order for me to be able to eliminate anything. So it's hard to make this a negative 3x, and it's hard to make that a negative 2x so that I have opposite. So what I'm going to do is I'm going to use a concept you learned back in 6th grade, least common multiple. I'm going to say, well, what can I make? What's a number that 2 will go into and also 3 will go into? And the answer is 6. Both of them will go into 6. That's its lowest common multiple. So what I'm going to do is I'm going to make one of these equations say a 6x and the other one say a negative 6x, because that way they will eliminate each other. So I'm going to make this first equation become a 6x. And so I'll kind of bring that work over here on the right side. And I'll color code it. So in order to go from 2x to a 6x, I'm going to multiply this entire equation by 3. So I have 3 times 2x, and that's going to give me 6x. And then 3 times a negative 3y is going to give me a negative 9y. And a 3 times a negative 2 is going to give me a negative 6. So now in a different color, I'm going to try to make this equation result in a negative 6x so that I have an opposite variable. So you're like, well, what do I have to multiply 3x times in order to get a negative 6x? And the correct answer is I'm going to multiply by negative 2. And watch what happens. We have negative 2 times 3x. That's going to give me a negative 6x. And a negative 2 times a negative 2y is going to give me a positive 4y. And a negative 2 times 3 is going to give me a negative 6. So now I've got my 2 equations set up where something can be eliminated. These guys right here, they're opposite. So those are eliminated. So now I'm going to combine a negative 9y and a positive 4y. I end up with a negative 5y. Got to think back to 7th grade on that one. A negative 6 combined with a negative 6 is a negative 12. I divide the left side by a negative 5, divide the right side by a negative 5, and I result in, well, a negative divided by a negative is going to be a positive 12 over 5 is what y equals. So now what I'm going to do, and I'll do this in red, I guess, is I'm going to take that 12 over 5, that's what y equals, and I'm going to sub it in for one of my equations and for y. So whenever I do that, I'm just going to use the second equation. It doesn't matter. So we have 3x minus 2 parentheses equals 3, and in the parentheses I'm going to put 12 over 5. I'm going to go ahead and turn that into a fraction, 2 over 1. So now whenever I multiply 2 times 12, that's going to give me a 24. And a 1 times 5, that's going to give me a 5. And then this is a negative times a positive, so that's going to give me a negative answer. So now my equation looks like this. 3x minus 24 over 5 equals 3. I'm going to add 24 over 5 to both sides, because that's the opposite of subtracting it. 4 over 5. And this is when I'm going to do this in a different color. We got to set up equivalent fractions, because you got to think back to 6th grade. When you're adding or subtracting fractions, you have to have a common denominator. So in this case, I have a positive fraction and another positive fraction that I'm combining. A common denominator, a number that both 5 and 1 will go into, is 5. So here we go. I'm going to put 5. So I'm going to multiply this bottom number times 1, because 5 times 1 equals 5. Therefore, 24 times 1 equals 24. And then 1 times 5 equals 5. So I need to multiply the numerator times 5. 3 times 5 equals 15. Now this is easy. My signs are the same. You learned in 7th grade that if your signs are the same, you're just going to add. So I got 15 plus 24, and don't forget that your denominator stays common, stays the same, so it's still going to be a 5. And we've got 5 plus 4 is 9, and 2 plus 1 is 3, so 39 over 5. And then don't forget this guy down here, bring him down. So we have a 3x equals 39 over 5. So the only thing we have to do to finish this up is I'm going to divide the left side by 3, and I'm going to use the old-fashioned division symbol. Divide the right side by 3. And you might say, well, Mr. Lewis, Dr. Lewis, whatever you're calling me, hey you, why are you using the old-fashioned division symbol? And the reason is because in 6th grade you were taught how to divide fractions. And this is how you most likely learned, is through 3 letters. Keep it, change it, flip it. And so what that means is I'm going to keep this first fraction the exact same. So 39 over 5. Change it means I'm going to change that from a division to a multiplication symbol. And then flip it means you're going to do the reciprocal. That means that's a fancy word for flip your fraction. So it was 3 over 1, now it's going to be 1 over 3. Alright? So 39 times 1 is 39, and 5 times 3 is 15. This can be simplified. I can divide both the numerator and denominator by 3. And when I do that, 3 will go into 3 one time, 3 will go into 9 3 times, 3 will go into 15 5 times, and so I'm left with x equals 13 over 5. So there we go. I've got x equals 13 over 5 and y equals 12 over 5. Those are my 2 answers.